3, 2, 1. Lesson 13, we're having our first look at graphs of circles, and as always mathematicians like to represent the same information in different ways. So the first way that we're having a look at is centre radius form. The mathematical definition of a circle is the set of all points which are equidistant from a fixed point. So our centre is the fixed point. The radius is the distance that every other point is from the centre point, and then the circle is all of those points. So it's kind of a little bit like if you had a peg in the ground in the centre and a chain with a big pen on the end, and you just went round and put dots with the chain fully stretched out the whole way around. Those dots, once you did an infinite number of them, form the circle, and they are all exactly the same distance from the centre. Before we have a look at the equation of the circle, we're going to just have a look at the general form of the circle, which I've got here for you. This is x squared plus y squared equals 1, and given that the constant term on the end is our radius, it's actually x squared plus y squared equals 1 squared. 1 squared is 1 though, so we don't write the squared. And the centre of the circle, as you can see, is at 0, 0. And you may recognise this as the unit circle, because that's exactly what it is. So this is the equation for the unit circle. The fact that the centre is at 0, 0 is significant because when we have a circle, the equation of a circle written in centre radius form, we can read the centre off. So let's say we move the centre of this circle up to here, which is 1, 1. We're not going to change the radius, so the radius is still going to be 1. Whoops, there's a very wonky circle. The equation of this circle is going to be not x squared, but x minus 1 squared. Notice that we've moved one unit to the right, so that is x minus 1. Now, we're happy with that idea. We're happy with x minus translates it to the right, x plus translates it to the left. Something that we're not quite so familiar with is when we do the same thing to y squared, we move it up, and the temptation is to go, oh, well, we've translated it vertically, so we're actually adding 1 on. But in actual fact, because we're translating vertically and we're adjusting the y coordinate, not the x coordinate, it does the same thing. So an upward translation results in minus 1. A downward translation would be plus 1. And the radius is still the same, so it is still 1 squared. So this is where our formula comes from. Both of them, in both translations in the positive direction, are expressed as negatives. Both translations in the negative direction are expressed as positives. So for example, if I was going to do the circle situated over here, which is negative 1, negative 1, still with the radius of 1, then this one would be x minus negative 1. You can think of it like that, all squared, or you can simply think of it as a move to the left, translation to the left means plus 1, all squared, plus, and our y is translated down, so it's going to be y minus negative 1 squared, which is y plus 1 squared, and that equals 1 squared, the radius. We need to be okay with the idea that minus negative is plus, because the centre is actually, the centre of the circle is actually this and this. This first one is our x coordinate and this is our y coordinate. So for the centre for this one is at negative 1, and our radius is 1. So let's go back and have a look at the equation of the circle. So the equation of the circle is x minus a all squared plus y minus b all squared equals r squared. A couple of things. This plus in the middle is always, always, always a plus. It's never a minus. The radius is always expressed in terms of r squared. The radius is not just the constant on the end, it's the square root of the constant. And notice that if x is the a coordinate, then this part of the function is x minus a. B is the y coordinate, so this part of the function is y minus b. So it's effectively the opposite sign of the way it appears in the function. So is the equation of a circle a relation or a function? Remember, if we're going to do the vertical line test, we can draw an infinite number of vertical lines that will cut the circle in both directions. So it is a relation. And the justification that we would give is simply that the circle graph fails the vertical line test, and that's all we would need to put. Why is it called center radius form? Well, think about slope-intercept form of a straight line, which is y equals mx plus c. It's called slope-intercept because there's the slope and there's the y-intercept. We can read it straight off the graph. And the reason that the circle is called, this version of the circle is called center radius, is that we can read off both the center and the radius. So this tells us that the center is at A, B, and the radius is R, not R squared, just R. All right, does the equation of the circle look familiar? How is it related to the formula for the distance between 2 points? If you would like, pause the video, have a go at see if you can make the distance formula into the equation of a circle. And what you should find is this. So distance is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. We square both sides. Distance is x2 minus x1 all squared plus y2 minus y1 all squared. Now, instead of having the distance between 2 points, we're going to have every point, which is represented as x, y, and so that's every point, and then a fixed point, AB, which is going to be our center. So now instead of finding the distance between x2 and x1, what we're going to do is find the distance between every point and the center in the x direction, and every point and the center in the y direction. And then when we do that, the distance is no longer the distance is now the radius. So that's the connection between the two. In the next little video, I'll go through the next examples and work out how to deal with these circles.